my name is Vinod. I'm going to talk about why SD-WAN is essential for your digital transformation. Just talk about the driving factors for SD-WAN and also go over VMware SD-WAN components, VMware SD-WAN solution components, and then just give a quick overview on what are the different working groups, the ONUG working group that VMware is actually working on, right? And also quickly on the AIOps working group, so we're going to talk about the demo that we have and just go over quick details on that, right? So quickly, why SD-WAN, right? I mean, if you look at the current state of enterprise WAN, most of the applications have been hosted in the data center, and all the traffic today coming from the branches are backhauled to the data center, right? So you have a centralized firewall, and all the traffic needs to go out to the internet, backhauled to the data center, and inspected. Any applications that needs to be any applications that needs to be accessed within a data center, so the users access it, and then if any traffic that needs to go out to the internet, so we inspect the firewall inspects it and then sends it off to the internet. So with the advent of cloud computing and software as a service, the applications which were centrally hosted in data centers, they're actually moving towards cloud. So here, there comes a point where the users who are backhauled all the way to the data center, that's not an efficient mechanism anymore, right? They need to actually go out to the internet to access these applications, cloud-hosted applications directly out of the branch sites. And backhauling, for one reason, it's not efficient because, again, it introduces a lot of latency. So there are real-time applications today like voice and video. If you look at Office 365, Skype, they're all hosted in cloud today, right? And backhauling all these traffic to the data center is actually not a viable solution due to latency concerns, of course, right? So keeping the application movement to SaaS in mind, and also talking about the operational expenses, right? So more and more customers today, they use MPLS to backhaul all the traffic, and with the increase in applications for IT productivity or any kind of applications that is used for enterprise productivity, backhauling all the traffic is going to increase MPLS or a dedicated link expenses, right? And one of the reasons for SD-WAN is also kind of reduce that operational expenses. Use internet as a viable solution to actually transport the traffic as well, right? So just talking about the operational expenses as well, right? It's not just the MPLS cost which adds up. There are actually other things as well, right? With the advent of cloud computing, there is actually a need where you need to classify the particular application traffic and send only that application traffic to the internet. So you need like modern mechanisms which can actually classify a particular application traffic as when you look at the legacy applications, they actually only look at just layer 3 or routing information, right? So all the traffic would actually go, all the traffic destined to a particular destination go down to a particular data center or to a particular destination, right? So with actually an SD-WAN solution, there is an important requirement where you classify these application traffic and send it off to the particular destination rather than depending on just on a layer 3 destination. So this is just a slide which gives you an idea about how the operational expenses come into perspective, right? With MPLS, we see that the per megabits per second cost is almost like 50 to 100 times as compared to the broadband cost, right? That's where the operational expenses come into play with respect to SD-WAN. And also, one of the things is we see that a lot of complexity is moving out of on-prem to like cloud. SD-WAN aims at solving that, right? So one of the things with respect to SD-WAN is extract all the complexity which is in the branch and then move it to the cloud, right? So when we talk about some of the next things about SD-WAN, we'll actually go a little more in detail what we are doing in the future, right? So, but the thing about SD-WAN is, with this slide, what I want to convey is, when we look at our solution components as well, it becomes pretty evident that we actually try to extract most of the complexity which is there on premise, and then we are trying to actually have an SD-WAN solution, abstract it, and then present it in a simplified way to the user. So the key capabilities of an SD-WAN, right? It should be transport independent. When you deploy a particular SD-WAN device at a branch, you will have MPLS, you will have internet, or you will have LTE connections. So it should be transport independent of what kind of connections which go out to the internet, right? And also provide a secure overlay, right? Encrypt the traffic, so when it's going out on an open internet, encrypt the traffic and send it off to like a centralized data center. Also encrypt the traffic and send it off to like cloud destinations, right? And also offer dynamic path selection. The dynamic path selection is more of, hey, am I able to actually select a path based on certain criteria, SLA criterions, right? So jitter, packet loss, or also latency, right? So I have my video, voice, and any business transaction applications. Each category of applications, they have different requirements. Am I able to categorize those traffic? That's where the application classification comes into picture. And then am I able to actually use multiple links to send those traffic across on different types of links which are available to go out to the internet, right? And finally, the important thing is a simple interface, right? With respect to operational expenses, one of the things that the customers talk about is, hey, I want to actually keep my operations and support team lean, right? So when you actually deploy a particular branch device in a branch, I want to make sure it can be deployed as easy as possible. They don't need like somebody who's actually well-versed with networking constructs or the networking technology in order to deploy a box, right? So having a simple interface, right? Go deploy the box, provision it, and also have a simple interface to talk to other technologies, be it like a network management or be it like a firewall or any kind of other technologies, have a simple interface to talk to it. One point on the simple interface is what we have is we have an orchestrator which goes and then does configurations and then gives you visibility in terms of how the applications are going in and out of the branches and data centers. So having all these data available from a single from a single plane or a single point of presence is actually very important, rather than going then having like 1,000 different branches talk to a particular network management device is pretty complicated as compared to just one orchestrator talking to a network management device, right? So that's the simplicity part of it. So in terms of the VMware SD-WAN itself, right, we boil down to following advantages, right? So in the previous slide, we talked about certain important things that the new network administrators, they look for when they deploy or when they try to simplify their branch and then data center networking, right? So one is obviously, the first thing is the simplified WAN management, not just looking at, hey, how do I connect to a network management and stuff? In terms of day-to-day operations, how do I actually have a policy-based kind of configuration model? I don't have to go configure each and every branch device. I just have a policy-based model where I can say that, hey, for this particular application, this should be the treatment across the branches which belong to a particular group, for example, right? So simplified WAN management is one of the things which VeloCloud offers, right? And it also assured application performance. We talked about voice, video application, real-time applications which are hosted in cloud today, right? And these applications, which were traditionally hosted in data center before, would actually go through a more reliable MPLS connection, right? Now they have to actually use the internet transport. How do I actually make sure by using a SD-WAN-based solution, how do I make sure I can carry these real-time applications in an assured way? So that's actually one of the things as well. So we'll talk about our feature called DMPO, Dynamic Multipath Optimization. That kind of ties into the assured application performance umbrella. And then also managed on-ramp to cloud. So it's the managed on-ramp to cloud is something which VeloCloud offers in order to help customers easily on-ramp their applications to cloud, right? The feature or the solution component which fits into this requirement is a gateway. There is a gateway component in the solution. The gateway is actually orchestrated and then hosted by us in nearest POP locations, wherever the branch device is deployed. And then we actually, the gateways are in a close handoff to all the major SaaS providers, right? So what we do is the last mile of the internet, right, until the gateway, which has most of the unpredictability or most of the unreliableness of the internet involved. We try and get through the traffic through that last mile, and then we hand it off to the cloud provider front end or to the cloud provider gateway. So that's the manage on-ramp part of it. Just to kind of summarize this slide, right, our solution is kind of built on these three pillars: simplified WAN management, assured application, and also managed on-ramp to the cloud, making the SaaS applications or the cloud application on-ramp easier. So talking about the solution components itself, right? So we have an edge. So an edge is actually a box. I mean, we have a physical form factor, and then we have a virtual form factor too. So this is the appliance which sits on the branch or the data center edge, right? So the edge helps connect the LAN to the SD-WAN overlay and then also to the internet, right? So any traffic, depending on the policies that you've configured, can be carried over the SD-WAN overlay or can be actually sent directly out of the internet. So this is the box which actually connects the internet to the branch and then the data center local network, right? And also, we have an orchestrator. Like we talked about, it's a single point, or it's a single plane where you go and do all the configurations. You actually look at all the statistics. You look at all the other data, in fact, like how are my applications is doing, right? What are the, how is the VMware SD-WAN application remediations? So after the application of remediation, so what is the application performance, right? And also, we talked about the gateways. The gateways are actually they are actually hosted at the nearest POPs, and all the edges, once they are deployed, they are activated with an orchestrator. They form tunnels to the gateway, right? And then the traffic which goes out to the SaaS destination is securely carried across those tunnels to the gateway. So we obviously have two different deployments, right? One is an enterprise-based deployment, and the other one is service provider-based. So the idea behind having two different deployments is obviously we have enterprises just directly go with our partners, and then they go for the SD-WAN service, and then we also have service providers who actually go and who actually sell our SD-WAN service to their customers, right? So the whole idea of having two different models is we give that architectural flexibility, right? A customer who's with a service provider, he may have MPLS service and then he may have internet service as well. So with our gateway architecture, we are able to aggregate the traffic coming from a customer from the internet and then also from the MPLS circuit to a single point of presence, right, which is the gateway. That's one of the reasons we have like two different types of architecture, and then having the gateway kind of actually simplifies it. So one of the things about carrying traffic on an internet is you need to actually secure the traffic, right? And what we do is with respect to cloud VPN technology, which is part of our solution itself, we enable the traffic going from, say, for example, edge to the gateway or to edge to a data center hub, right? We encapsulate the traffic and we encrypt the traffic and then we send it across. I think the beauty in it is everybody does encryption and then everybody sends the traffic. It's actually simplifying this, right? You just say that, hey, I have a hub and then I have all these gateways. You you have them in a profile, and then once you actually just click enable cloud VPN, we automatically create VPNs between all those devices, right? So that's the beauty of it. And then also what we do is, one of the things about cloud VPN is having a gateway kind of simplifies a lot of VPN topologies, right? So if you have like a security service like Zscaler, or a cloud security service like Zscaler, or Palo Alto Prisma Access, right? You don't have to, the customers don't have to go create IPsec tunnel from each and every branch, right? We create an IPsec tunnel from the gateway to the particular cloud security service, and the edges, they talk to the gateway automatically. So in a business application, you can just say that these are all my internet applications which need to actually go to the cloud security service for further inspection, right? Once you define a business policy, the edges will actually send the traffic over the secure tunnel to the gateway, and the gateway actually sends the traffic to the cloud security service, right? So that simplifies kind of the configuration model as well. So in terms of the security itself, right, of late, whenever we talk about SD-WAN, there is actually a big onus on security. Hey, the traffic, we are exposing the branches to directly talk to the internet. What about security with respect to SD-WAN solution? The native security elements that I talked about is naturally, hey, we have the IPsec tunnels where we secure traffic and then send it across. And then also, what we do is we have an inbuilt firewall where we allow only the connections which are actually starting from inside. So any connections which come from outside, you need to either explicitly enable it, like a port forwarding rule, otherwise we will not enable it. So that's the built-in firewall capability. So what we do is certain customers, they want like advanced next-gen firewalling, like IPS, IDS, or anti-malware to be there on the branches as well. So what we do is we also partner with likes of Palo Alto Networks and other vendors. They are able to actually run their software on our hardware. So we have hardwares 520V and then 840 which support these VNFs. So you can service chain the traffic coming from LAN going out to the internet through the firewall, right? That's the firewall VNF option. There is actually centralized firewall. A lot of customers still, they want to actually centralize their firewall, have the traffic backhaul to the data center, and then have it inspected by the firewall and send it off to the internet. So what we do is, in order to support those deployments, what we do is we actually simplify the configuration on our side. We just say that all the internet traffic backhaul it to a particular hub site, so all the traffic will be backhauled. You don't have to actually do a much more extensive configuration than that. And then with the advent of all the cloud security providers, we see a lot of customers moving to consume security through the cloud as well, right? So that's where we have integrations with the cloud security providers like Zscaler, Prisma, and there are a couple of others as well, right? So what we do is we form a tunnel from the gateway to the cloud security provider, and also we are trying to enhance those integrations, right? For example, with Zscaler, we do some kind of API automation. We figure out, hey, where are their nearest nodes located, and then we see what is the nearest gateway to them, and then we automatically create tunnels between those two. So there is actually a big kind of initiative inside to actually improve that integration as well, right? Making the integration points less configuration intensive and then more automatic, right? So we talked about security. The next thing important is the application assurance. We talked about all the real-time traffic going out to the internet. Dynamic multipath optimization, that's actually a technology name that we have for a suite of implementations that we have internally. We do, obviously, in order to actually identify what application category it belongs to. Hey, is it actually a real-time voice traffic, or is it actually a real-time video, or is it actually a business transaction traffic? We need to be able to identify what kind of application it is, right? So with the deep application recognition, what we do is we have like a 3,000 plus application database, right? And then we are able to identify the application. Because of this database, we are able to identify the application at the first packet itself, right? When it's going to a particular cloud. So we look at, hey, what is the FQDN or what is the IP address it's going to, and then we identify that this is the application, right? And then we put it in a proper category. And then we also have heuristics, right? If it's not a well-known application, we try to identify at least what base application it belongs to afterwards. So that's the deep application recognition part. I already covered the secure overlay. The secure overlay, obviously, the IPsec tunnels that we talked about, and then also the tunnels from the gateway to any kind of cloud service provider, right? And the link qualification. The link qualification is more of, hey, how are the links behaving? So since we have the gateway, we are able to actually monitor the traffic in and out of link, right, from the gateway standpoint, and then we are able to figure out, hey, what is the delay, jitter, and then the packet loss on this particular link, right? So having a gateway architecture kind of actually gives us that flexibility, right, of all the other advantages that I talked about as well. Application steering, right? This is, hey, I identified the application. Now, what I want to do is I have 2 internet links, and then I have an MPLS link, right? Or I have 2 internet links, 1 LTE link, and then 1 MPLS link, right? I want to, since we monitor all the links, so what we can do is, with respect to application steering, we can figure out, hey, for voice and video, this internet link 1 is good. For voice and video, the second internet link is not good. So I'm going to send my voice and video on internet link 1, but I'm going to send my transactional video on internet link 2, which is actually good for transaction video. It depends on all the SLAs, on all the parameters and stuff, right? So that actually comes to an important kind of feature as well, which is actually aggregation, right? So I can actually aggregate multiple links, and then I can actually send traffic out of the multiple links, right? And the final one is on-demand remediation. I kind of actually touched about aggregation there, but on-demand remediation is I can actually take a particular flow, and then I see that, hey, there is some problem with the current link which it's going to, and then I can apply some kind of remediation policy. Either it can be like packet duplication to improve voice quality or video quality, or if I have a better link, I can actually move that flow to a better link, right? So with the presence of the gateway architecture, it actually helps us, right? Whereas some non-gateway architectures, you have different WAN IP addresses, right? So you cannot actually move the flow in mid like to another link, right? So, so this is just to give you an idea, like when I talked about the configuration simplification stuff, so how our business policy rules are defined. So it's again application-based, right? So it's not like a traditional routing. And then also we have application-based QoS as well, right? Depending on what kind of applications you have, you can define application-based QoS. And we talked about the dynamic path selection. You can actually go select, hey, this application is important, so I want to actually offer like application assurance and dynamic path selection to it, right? So this just gives a very quick overview on how our business policy rules are defined as actually opposing to the legacy networking, where you need to define QoS, ACLs, and like policy-based routing and stuff, right? So this slide pretty much gives you a very good overview on how the dynamic path optimization works. So one of the important things to note that we actually do a per packet base, since we have the gateway in the internet. So we are able to take like 2 or 3 internet links, and then we are able to figure out, right, at a given point of time, which internet link has the best quality, and then we are able to actually steer that flow to that particular internet ring, right? And that's what the VeloCloud enhancement on the top talks about, right? We took a particular flow, there were like 2 or 3 links which had like probably a bad latency or packet loss, and then was able to actually steer it, and then steer it to better links around the time, and then it was able to actually give proper quality of service to that particular application. And that VeloCloud enhancement tab on the top, the VeloCloud quality score, it actually talks about how the VMware SD-WAN was able to apply all the mitigations for a particular application category, and then steer it, offering good quality of experience to the users. Okay, so we talked about a lot of things about why SD-WAN, and then we talked about the solution components, we talked about the security architecture and stuff. So quickly, what are the emerging trends on the WAN edge, right? So with the gateway architecture, we can connect to any kind of cloud, right? Multi-hybrid or like public cloud, private cloud, right? And then also, we talked about the native security as well. One of the things about SD-WAN is kind of abstract any kind of complexity which is on-prem and then move it to the cloud. I think with security also, we are kind of actually following the same thing, right? How do we actually see that there is actually minimalistic security which is required on the branch, and then all the complex security features, right? How do you actually move it to the cloud? And also, how do you offer segmentation, right? When the traffic has to go from client, cloud to a particular container. With NSX and also the other NSX-related components, we are able to actually offer that segmentation all the way from client to the particular container. And hyperscale. So our gateways are kind of stateless just to make it easier. So even if the scale of the traffic increases from a particular customer standpoint, we are able to horizontally scale our gateway in order to give that cloud scalability factor, right? So with all this, we are going to focus on advanced analytics, right? All the data that we can actually get, and then take some enforcement actions, how we can self-heal networks, self-heal like applications using this data. This is what we are going to be focused on moving forward. In terms of the VMware participation at ONUG itself, so we have, obviously we have like multiple business units within. They are focusing on like different workshops, so they're working with different groups. On the VMware service-defined firewall side, so I think we were the first kind of solution, security solution vendor to get validated. And on the VeloCloud side, I'm going to just cover it in the next slide. So we are working with the AIOps work group. The idea is we collect data into an S3 bucket. So this could be any vendor, and then use the data to give like better visibility, and then also give better insight into like what is going on within the network, right? And obviously on the load balancing side, with the recent acquisition with Avi Networks, they are also working on the hybrid multi-cloud security working group. So this is essentially the AIOps group concept. I think we will have a demo tomorrow, so do take some time to come by and see it. The data will be exported to S3, and then the AtScale has their own virtualization layer, which they're going to actually use in order to actually show more insights. So it will be Mist and VMware. So Mist is actually the access point, and VMware SD-WAN Edge. So we both will export data, and then we'll try and actually show you some scenarios where we can show some insights through the branch, where the flow is coming from, which edge it's going, and then which path or which link it's taking out to the WAN link, right? So that's pretty much just to make sure we have certain books. If you're interested in SD-WAN, if you want to learn more about SD-WAN, we have books. And also, if you're interested to know more about the VMware SD-WAN technology itself, there are actually certain hands-on labs that you can refer, that you can actually go, and then you can actually do as well on the VMware HOL Labs website. So do actually make a note of that. Obviously, it will be in the presentations that you receive. And with that, I conclude. Thank you so much for coming.